Okay, freshmen and sophomores, this is for Algebra 1, first period, Algebra 1, third period, who I'm not going to see you guys at all this week. So this is the first of 2 videos that's going to help you do the assignments for this week. So I will be posting these. I'm going to send you an email that's going to tell you where I'm posting these videos and where you can find them. Well, it's not going to help you if I'm telling you this, but you can't find it. But you will have found this video, and this should help you do the assignments for the week. So today we're going to talk about algebraic compound sentences, okay? And I just want to refresh your memory what a compound sentence is. So let's look at a couple compound sentences from English. First one, I went to the store and I bought a loaf of bread. Now, if you remember, a compound sentence is 2 complete thoughts. So actually 2 complete sentences that can stand on their own, but they're connected by the word and, or but. So that's an example of a compound sentence in English. Here's an example of another compound sentence. I will cook dinner, or we will order pizza. I will cook dinner is a complete sentence on its own. That can stand on its own. We will order pizza. That is a complete sentence on its own. When I connect them with the word or, I have formed a compound sentence. Same thing with the first one. I went to the store is a complete sentence on its own. So is I bought a loaf of bread. When I connect them, I make a compound sentence. Now, if you were in class, I would do this activity with you that's kind of hard to do when you're not here, but we need to understand the difference between the word or and. So let's say Mrs. McCullough has a theology class, a freshman theology class, 7th period, and I have an Algebra 1 class, 3rd period. If Mr. Franzinger came over the PA and said, I need to see any kid after school in, I don't know, room blah, 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 if you have Mrs. McCullough, 7th period, or Mrs. Antonelli, 3rd period, would you go if you were only in one of those classes? Like you had me, 3rd period, but you don't have Mrs. McCullough. Would you still go see Mr. Franzinger? Yeah, you better, and you would, because he used the word or. So you don't have to be in both the classes, you just have to be in one to be included in that group. Now, if he got on the PA and said, I need to see anybody who is in Mrs. Antonelli's 3rd period class and also in Miss McCullough's 7th period, then you would only go if you were in both of those classes, okay? So there's a difference between saying and or, okay? If, you know, Mr. Fitzpatrick came over the PA and said, I need to see any kid who played football or basketball, any freshman that played football or basketball, you would go if you just played football, you would go if you just played basketball, you would also go if you played both. Now, if he said, I want to see any kid who played both football and basketball, then you would only go if you did both. Does that make sense? So and means it must be in both, or means it can be in either one. All right, so first thing you're going to have to do on your first homework is you're going to have to graph some or statements. So you're going to get something like this. And you're going to have to graph that on the number line. So this is going to be pretty easy. So I'm going to have 0, 1, 2, 3, 4, 5. And this way I'm going to have -1, -2, -3, -4. And I want all the numbers that are greater than 3. So that would be all of that. or less than -2, and that's going to look like that. So this would show me, and if somebody was standing out in the hall, one of your friends, and you were trying to describe that set of numbers to him and he couldn't see it, wouldn't you say, oh, well, she graphed everything that's greater than 3 or anything that's less than -2. So this is what that graph would look like. Everything greater than 3 or anything that's less than -2. Okay? If we had to do x is less than or equal to 0 or x is greater than 3, whoops, what would that one look like? That would look like this. -2, -1, 0, 1, 2, 3, 4. Okay. I would want anything less than or equal to 0. Now, since it's equal to, we got to fill it in. Less than goes that way. Or I want anything that is greater than 3, so that would be there. So any number on the number line that falls under one of these green arrows is in either this set or that set, or possibly both, but there aren't any in this case. Okay? So that's how we graph. Now, how do we solve a compound sentence? Or what does a compound sentence look like? Well, a mathematical compound sentence looks like this. Just like an English one, it's two complete sentences separated by either the word or and. That's how the mathematical compound sentence is. So this whole thing is an example of a mathematical compound sentence. In this case, it's a compound inequality because these are inequality signs. So what we're going to do, this is really pretty easy. We're going to just solve each of these inequalities because they stand by themselves. We're going to solve each one on its own. So this one, I'm going to add 5 to both sides. Oops. Actually, guys, if this is supposed to be a 1, sorry about that. I misread it off my paper. So I'm going to add 1 to both sides. Remember, I told you you could do that mentally and, not have to show that little step. And then we're going to divide by 2. And that's going to give me x is less than 3. So that says any number greater than 3 will make that statement true. Or I'm going to solve this one. First step to solve this one is to subtract 6 from both sides. So I'm going to be left with -2x is greater than 4. Now be careful here. What's my next step? I have to divide both sides by -2. Ding, 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 ding. Red light's flashing. I'm dividing by a negative. So that means I have to reverse my inequality, and I'm going to get x is less than -2. Now, I do want you to graph this solution set. So this is just what we were doing. Here's 3, 4, 5. Here's -1, -2, -3, -4. Okay, so I want my final solution is going to be anything greater than 3 or anything less than -2. Are we okay with that? Okay, let's do a tricky one. Let's do another one. 1/2 x minus 6 is greater than -4, or all of these that I'm doing today, the 2 worksheets that you have, one are all compound sentences using the word or, and one is compound sentences using the word and. So these are all going to be ors right now. Got that? So the first thing we're going to do is we're going to solve each of them separately. So I'm going to add 6 to both sides. So that's going to be 2. Then I've got to multiply both sides by 2 over 1. Whoops, 2 over 1. And I'm going to get, those are going to cancel, and I'm going to get x is greater than 4. I don't reverse it because I multiplied by positive 2, not negative 2. Or, here I'm going to add 2 to both sides. You don't have to show that step, but I'm showing it. Then you divide by 3. Again, I'm not dividing by a negative, so I'm not switching the sign. Okay, now, this one's a little bit different. You can't be on autopilot. You got to be looking at this. So here's 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2. All right, so first set, I have to graph everything greater than 4. So that's everything that way. Does that make sense? Now the second one, what do you notice? This one's a greater than 2 in this case. So that's going to be everything greater than 1. Now this is the part you got to pay close attention to. They're not going in opposite directions. So now if I asked you, I'm going to do my final answer in red. What numbers on the number line fall either into this set or that set or possibly both? So any number at all that's underneath either one of those blue lines, wouldn't you agree that it's going to be anything from 1 out? So any number here, 2. 2 is in this set. It's not in that bit, but it doesn't have to be in both. It has to be in either one. It can be in both, but it doesn't have to be. 5 is in both. So any number from here down would be in my final answer. So we would get rid of these, and my final answer would be anything greater than 1 in this case when the arrows are going both ways. Okay, so that should be enough for you to get started on this assignment called Compound Sentences 1. Okay, on the top part, you're just going to graph, and then on these two and on the back, you're going to solve and then graph. Are we okay? All right, so I suggest you stop and you do this worksheet, then go and pick up the next video, and then that'll give you what you need to do compound sentences number 2. Okay, good job, guys. Bye.